Hello everyone. In this video, I'll be explaining you about the array manipulation problem in HackerRank under the arrays subcategory in the interview preparation kit. So if you must have gone through this problem, you'll be knowing that in this question we are provided with a multi-dimensional array along with some set of inputs. So the input format goes something like this. The first element represents the size of the resultant vector of the array. The second element represents the number of subqueries which and the next few lines has the number of the list of subqueries with each with three elements. The first element and the second element specifies the index, start and end, and from where till where we have to add the third element, which in this case k is equals to 100, and hence we have to return the maximum element in the resultant vector, which in this case is 200. So let's get to the explanation part to understand it well. First, we make a vector which has a size of 5 and each element is set to 0. Then, after the first operation, that is 1, 2 and 100, from the first index to the second index, we add 100 to each element, which results in having the first and second element as 100 and the remaining elements as 0. After the second operation, from the second element to the fifth element, when we add 100, only the second element has the value of 200 and the remaining elements have a value of 100. After the final operation, that is 3, 4 and 100, after adding the 100 to the third and the fourth index values, we get an element in which we get a vector in which the first and fifth element is 100 and the remaining element are 200. Now we have to return the maximum element out of this vector, which in this case is 200, and that is returned by the function. So there are multiple approaches to solve this problem, but the most common approach that comes into mind is running a loop for m, that is the number of subqueries, and the second loop from a to b, and then altering the values at those indexes. But to bring to your notice, when the size of m goes up till 2 is to 10 raised to power 5, then there is probably a chance of making your solution with have a complexity of order of n, which is not optimal. Hence, to make the problem quite optimal, the approach that I would be using over here is the prefix sum array approach. This will make the solution of order n and hence will reduce this complexity and will provide a better solution in my point of view. So the first question comes to the mind is, what is a prefix sum array? To bring into a simple term, the prefix sum array at a position I is nothing but the sum of the elements of the actual array from the 0th index up till that ith index. In the example, you can see we are provided with an array in which the values are 10, 20, 10, 5 and 15. Hence, its equivalent prefix sum array will be at the first index, the 10 is just going to be the same as the first element in the normal array. Then the second element is going to be the sum of the first and the second elements of the array, that is 10 plus 20, and hence we get 30. The third element is going to be the addition of the first, second and third element, that is 10 plus 20 plus 10, that will give us 40. And similarly, we obtain 45 and 60 after adding 5 and 15 respectively to the given elements in the prefix sum. Now, coming to the part, how are we going to use this prefix sum array inside our to solve this question? For this, let me bring you to the demonstration that I've made to make this problem look easier. First of all, I've just copied the given sample input from HackerRank over to this whiteboard to explain this problem to you. So we can see that firstly, we need to create a vector that has size of +1, n plus 1. And the reason for that is, for which I'll just come in a while, why we are taking a vector which has size greater than the actual value. Uh, so the basic approach that we are going to use in this problem is rather than adding 100 to all the indexes from the starting A till B, we are going to add 100 only where at the 8th index, and A means here A is 1, so we are going to add 100 to the first index, and we are going to minus 100 from the index that is b plus 1. In this case, b plus 1 would be 2 plus 1, that is 3. So we are going to minus 100 from the third index. Similarly, for the second operation, you can see we are going to add 100 to the second index, and we are going to minus 100 from b is equals to 5. So 5 plus 1, that is equals to 6. So we are going to minus 100 from the sixth position. Similarly, when for the third operation, when our a is equals to 3 and b is equals to 4, we are going to add 100 to the third index, and we are going to minus 100 from the fifth index, which is equals to 4 plus 1, 5. So we are going to minus 100 from the fifth index. Then we are going to start adding the values from the left to right to get a prefix sum array. That is, when we start adding from here, 100, the first element that we get in the prefix sum array at the first index, that is going to be 100. As soon as we reach the second index, we get 100 plus 100, that is will give us 200. As soon as we reach the third index, there is a minus 100 and plus 100 which cancel each other out, and hence the 200 will continue. In the third index we have no operation, hence 200 will continue. In the fourth index we have a minus 100, that will give us 100, and in the fifth index again we have a minus 100. Sixth index we again have a minus 100, which will give us 0. Now coming back to where I was when I told you we are going to consider a vector which has a size plus 1, n plus 1. That is because when we have b equals to 5, we can easily add minus 100. We can easily add minus 100 to the sixth location, which would not exist in the case if you would have considered the vector equals to vector size equals to n equals to 5. So here also I have mentioned that according to this, not n, basically n, this is n. If a n is 6, 1 to 6, why question? Because there in question they have taken the value of a and b from 1 to n. But you know our vector indices are always from 0 to n minus 1. So our vector indices are going to be 0 to 5. And this is also going to be used later. That's the reason I'm explaining you. And as soon as we get the prefix sum array, we are going to return the maximum value out of this array, which in this case is 200, and hence our function will return 200 to the main function for it to display on the console. So here we come to the implementation of the code, implementation of the logic, that is the coding part, and the most important part to understand this problem. So we can see over here that we have provided with a function arrayManipulation which has a return type of long, and it has arguments n, which is the size of the resultant vector to be formed, and this is a two-dimensional array which contains the subqueries. So first, basically what we are going to do is we are going to create the resultant vector, but with the data type of long. And the reason for taking long and not int is because when we add multiple values with the range of, as we can see that the range of the value k is up till 10 raised to power 9. That means when we add multiple values of the order 10 raised to power 9, there is a possibility that the data type might convert something which is greater than int, and hence int will not be able to store it. That's the reason we are taking a vector that has a long data type. And also, if you notice, we have the return type as long, and that's the reason we have a return type as long, and that's the reason we are taking a vector of data type long. so that it contains elements of data type long. Then we are going to traverse the row of the multidimensional array. In this case, as you can see, if any multidimensional array has rows and columns, so we are going to iterate through the rows, and that's the reason for this multidimensional array queries I have taken I less than queries dot size. That means this is going to iterate through entire row, not through entire columns, through entire rows. And for the columns, I'm not going to iterate one more loop. Rather, since there are only 1, 2, and 3 elements, so I'm going to access them with indexes 0, 1, and 2. So as you can see over, and one more thing to keep into mind, since I have written over here vector indices uh, starts from 0, and that's the reason we are going to -1 whenever we are going to take the values of a and b. So coming back to our loop over here, we are going to iterate through the entire rows. Now what does v1? V1 is our v1. Okay, v1 is our vector. We are going to take the queries I0 minus 1. What is this going to return? I of 0 will not be nothing but a minus 1, for the reason vector indices start from 0, and we are going to plus equals to queries I of 2. And what is I of 2? I of 2 is your k equals to 100, because I of 2 is the third element and third element is k values. So we are going to add the k values to the 8th index. As we had discussed, to the 8th index we are going to add, so 100 will be added to the first position, and the reason of -1 is because vector indices start from 0. And also, if you must have noticed, I had made the initial value of all the vector elements to 0. Here, the first element specifies the size and the second element specifies the default value. So we had made the default value of all the elements as 0, and that's the reason when we plus equals to the k value, all the k values gets added to that. Now, to the b plus 1 element, we need to add the value of -100, and that's the reason I have done minus equals to queries of same the k value. Queries of I2 will give you the k value, I0 will give you the a value, and I1 is going to give you the b value. So now the question arises is, why have I not written here -1 and just written queries of I1? The reason for it is, anyways we are going to do a b plus 1. We are not going to add, as you can see, b is 2 but we are adding it in 3, -1 in 3. B is 5 but we are doing -1 in 5th index. B is 4 but we are doing minus 100 on the 6th index, and that's the reason we are always doing a -100 on b plus 1. So -1 and +1 would neutralize to 0, and that's the reason I'm not writing it itself. That's something that will happen on its own. Now we are declaring a max value variable, and we are initializing it to the base address of the vector. We are initializing it to the 0th index element, so that can be the default max value, for instance. Then we are iterating towards the entire length of the newly created resultant vector, and we are going to add, for each we are starting with 1 and we are going up till n minus 1, not till n minus 1. The reason is, however, the last element is going to be 0, so we are not concerned with it. We are just going up till n minus 1, and for each as soon as one of I, we are going to add its previous value, which is exactly the case of the prefix sum array. The prefix sum array works upon this principle, that is adding the elements before that. To get the element at the ith position, you need to add all the values from 0 up till the ith element. So you will get the get the element at the ith index. Next, the next thing is to find the max value. Max value is nothing but the by using the max function, I have found the max value out of the current element and the initial the previous max value that existed, and that is stored in the max value function, and the cycle repeats. The for loop is worked up till n minus 1, and we get each element of the prefix sum array by this operation, and we get the max value at that instant only by comparing it. If the max value is greater than the current value, then the max value becomes the current value. So as you can see over here, it will start from here 100. So initially the max value will be 100, then 200. So of course 200 is greater than 100, so max value will be 200, and then max value doesn't change. Even 100, it doesn't change, and that's the reason max value retains the value of 200. And once it comes out of the loop, we are returning the max value, which is of data type long. So it gets returned to the main function and it shows up on the console. Hence, we get the desired output. And as you can see over here, the overall complexity of our solution will be n, and for this loop, and n for this loop, which is order of to n, which is nothing but order of n, and hence provides a optimal solution. And to just show you how it works, I'm just going to run the code to see whether it passes all the test cases. And there you go, you see that the basic test cases are passed. I'm just submitting the code, and finally all the test cases have passed and we have passed the solution. So you see over here, this solution comes under the category of hard under the arrays subcategory, but we have written quite small code of around at about 10 to 11 lines of code. And yeah, now the problem seems quite easy after using the prefix sum array approach. So if you liked this video and if you got to know something out of it, please hit the like button and also share it with your friends who are still stuck with the problem and are looking for a better approach. If you have a better approach than this, please let me know in the comment section below. And I've recently started uploading some videos from the interview preparation kit section in my playlist of interview preparation kit. So if you'd like me to feature some special video, you could let me know, and also support my work by subscribing to my channel. Thank you. That's all for today. I'll meet you in the next video. Thank you.